Okay, this is second part of the section 3.6, and I'm going to talk about higher orders of polynomials P and Q, the numerator and denominator. Right now, well, in first part, we covered polynomials of the first order, like a linear polynomial on the top, like 2x plus 1, and linear polynomial in the bottom, like 3x minus 2, for example. Now, what if we have higher orders? For example, I'm going to kind of consider a polynomial of a second order, like 2x squared minus 4x plus 5, and x squared minus 2x plus 1. So how do we find vertical and horizontal asymptotes? Well, first, vertical asymptotes. For vertical asymptotes, we'll need to factor the denominator. X squared minus 2x plus 1. In our case, guys, it's going to be really easy because it's actually a perfect square. It's a perfect square of x minus 1. So my vertical asymptote is going to be x equals 1. Turns denominator into 0 means that most likely it's going to be division by a very small number and bring you to infinity. What to do with horizontal asymptotes? Horizontal asymptotes. Well, generally, guys, you can also use long division and divide numerator over denominator. But there is a simpler way to deal with it. Please watch how I will do it. We know that horizontal asymptotes, it's a horizontal line to which function approaches at infinity. Something like y equals a, and f of x goes to this line a as x goes to infinity, or x goes to negative infinity. So actually your function looks like a horizontal line at infinity. Let's see, will this function look like a horizontal line at infinity for some number? What I'm going to do, guys, please watch how I do this. I'm going to divide numerator and denominator by x squared. So I'm going to write down 2x squared over x squared minus 4x over x squared plus 5 over x squared. And in denominator, same, x squared over x squared minus 2x over x squared plus 1 over x squared. I'm going to simplify it a little bit. Here, x squared cancels, right? Here, I'm going to have 4 over x. One of these x's cancels. And here, 5 over x squared. Here, 1 minus 2 over x plus 1 over x squared. Now, what we can see, guys, when x goes to infinity, this term is going to be 2 over a very large number, will go to 0. This term will also go to 0. This term will also go to 0. Just because you have infinity in denominator means a very large number is going to bring actually the fraction to 0. So at infinity, these numbers are going to be very small. What we are going to have large is 2 and 1. And my function at infinity is going to be very close to 2. So we are going to say that y equals 2. It's a horizontal asymptote. Okay? Well, you'll probably ask me how to graph now, and maybe do we do this every time? Yeah, let's do the graph. I'm going to graph my vertical asymptote, which is 1, right, and the horizontal asymptote, which is 2. And now the question is, well, you know that function can come from the top to 2 and from the bottom to 2. From which sides it will go close to 2 at infinity? The best way to decide is to just plug in large number here and just see, is it going to be a little bit bigger than 2 or a little bit less than 2? Well, I don't know. I'm going to plug in maybe 10. So I'm going to plug in 10. So it's 2. If 4 by 10 is 0.4 plus 10 here is 0.05, right? Sorry, I mean this. And here 1 minus 0.2 plus 0.01. Oh, let's see what it's going to be. 2 minus 0.4, it's 1.6, right? So it's 1.6 and extra 5, 6, 5. In denominator, 1 minus 0 0.2, 0 0.8, 0 0.81. Or we can use a calculator and just figure out what it's going to be. I'm going to just find out. My suggestion, that's the best way to find out on which side it's going to be. So I'm going to use my cell phone calculator. I don't want to turn this off. So 165 divided over 0.81 equals 2. Well, you see, it equals 2037 and more digits. You see, it's already very close to 2, even just at 10. So at number 10 is very close to 2, but it's a little bit greater than 2. So I think it's going to approach on this side. You can repeat it over here. And the only difference going to be is that x is going to be negative, right, somewhere. Well, I'm going to do the repeating. So x equals 10 here. I'm going to set up x equals minus 10 here. So it's still 2. For this term is going to be plus 0.4 plus 0.05 because it's a square. 1 plus 0.2 and plus 0.01. Why it's plus? Because we're going to plug in negative 10, and negative 10 is going to turn these two minuses into pluses. Well, let's see. We are going to have 2, 4, 5, right? And 1, 2, 1. Is it going to be a little bit bigger than 2? Or, well, I do see it's going to be a little bit bigger than 2, because if I multiply this by 2, it's going to give me 242, and this is 245. So it's going to be a little bit 2 or something bigger than 2. So it's actually approaching on this side. Now we'll need to decide how the graph is going to look nearby 1. For nearby 1, we are going to kind of plug in numbers close to 1 into our function and see how it's going to behave. Let me kind of maybe use this form when I factor denominator. So it's going to be a little bit easier. So my function f of x equals, you write down 2x squared. Sorry, I kind of don't have a function in front of me. Minus 4x plus 5 minus 4x plus 5. And here x minus 1 squared. So if I'm a little bit over here, well, let's say 1.1. Then this expression is going to be what? 1.1 minus 1 is going to be approximately 0.1, right? If we square it, it's going to be 0.01, a small number, right? 1.1 here, here, and here is going to give me what? Well, it's almost 1. I'm going to just plug in 1 here. 1, it's 2 minus 4 plus 5. 2 minus 4 is going to be minus 2 plus 5 is going to give me 3. So it's approximately 3 over 0.01, approximately 300, right? So large number. Sorry, large number over here. Now I'll try to plug in number a little bit less than 1. 0.9, half of 0.9. And here I was plugging in 1.1, so I'm going to put 1.1. By the way, guys, for denominator, it's important how close you are to 1. 1.1, 1.2. For numerator, actual numerator is not sensitive to it because it's not turning into infinity. You just can plug in 1. So if I plug in 1, I'm still going to get 3 in numerator, right? And in denominator, I'm going to have negative 0.1 squared, which is again going to give me 300. So large number here. And sorry, turned it to red actually. I'm going to bring it back. So 300 and a large number here. Now I'm just going to connect these lines. That's going how the graph looks. So the graph is not going to look like a standard hyperbola. You see, it's taking the first and second quadrant, not like first and the third or second and the fourth. And there is more investigation if you have like higher order, right? More investigation because you will need to know how the graph approaches actually vertical asymptote and how the graph approaches horizontal asymptote. Well, that's a long problem, but we can do it. So I think I'm going to consider another example. But before example, I'm going to give you a general rule. The rule. If you do have Pn of x, polynomial of nth degree, divided over Qm of x. Then, how to find horizontal asymptote? If n equals m, then horizontal asymptote is going to be the ratio between coefficients an and am, the coefficients of the polynomials. I'm going to write down horizontal asymptote. If n is greater than m, there's going to be no horizontal asymptote. Well, it's just because this polynomial is growing faster than this. Can be like, for example, x to the power of 4, and that's a square. So you're not going to have a straight line here or a constant line. If n is less than m, there is going to be y equals 0 horizontal asymptote. Why does it happen? When n is less than m, for example, you have a numerator, just the first power, and denominator a second power. Then when you divide by x squared this, you are going to get 0 here. If this is not a second power, if you don't have this term, but start with this term, the first power, when you divide, you are going to just go to 0. It's going to be 0 over 1, still going to give you 0. So that's why. So actually, the rule about asymptotes works for like division by x squared or whatever the power of denominators works for these two cases. No, works for these two cases, and this one is exception when the power of numerator is greater. Usually, guys, if you divide by power of denominator, you're going to see if numerator has something going to infinity, then there is no horizontal asymptote. If it's numbers on top and the bottom, then horizontal asymptote is a ratio of these numbers. And if on the top you have 0, the horizontal asymptote is going to be 0. Let's consider an example. I think I can consider several examples. So example 4. So for now, guys, I'm not going to graph the whole graph. I'm just going to be concerned with horizontal asymptotes. And here 2x squared plus 7x, something like this, guys. What are going to be horizontal asymptote? Horizontal asymptote. Well, I'm going to divide by power of denominator. I have cube in numerator and a square in denominator. So I'm going to have 3x plus 2 over x minus 1 over x squared. I'm dividing by x squared here and by x squared here. The cube is going to give me just x. In denominator, I have 2 plus 7 over x. And what I know, this will go to 0 at infinity. This will go to 0 at infinity. This will go to 0 at infinity. More extra circles, 0 at infinity. So what I'm going to have at infinity is 3x divided over 2. Because x goes to infinity, it will go to infinity. So no horizontal asymptote. You see? Doesn't go to a number. Okay, that was case A. Case B, f of x equals 2x to the power of 5 plus 3x divided over 7x to the power of 5 minus 6x squared. Again, we divide by power of denominator, x to the power of 5, x to the power of 5. We are going to have 2 plus 3x to the power of 4, right? Because that was x, and you divide by x to the power of 5. 7 minus 6x to the power of, that's a square, 5. We are going to get 3, right? X squared cancels with 2 x's from denominator. So this will go to 0 because infinity denominator. This will go to 0, and we are going to have 2 over 7. That's going to be my horizontal asymptote. Horizontal. Sorry. Get a bit smaller. Horizontal asymptote. And the last example, just to verify the rule. X equals 3x plus 1 over 4x cubed plus x. So I'm going to divide by x cubed here and by x cubed here. So what I have, Well, here, because I have x and divided by x cube, I'm going to have 3 over x squared. Square, actually. Let me erase the whole thing. 3 over x squared plus 1 over x cube. Here, 4, and here, 1 over x squared. Now, guys, what I see, this will go to 0. This will go to 0. Whenever you have infinity at denominator, it will go to 0. This will go to 0. This is just 4. So I have 0 divided over 4, which is going to give me 0. That's going to be my horizontal asymptote. You see? Okay. So all three cases, powers are same. Now, power of numerator is greater than power of denominator. Let me write down this 3 bigger. That's equal, and numerator has smaller powers than denominator. Okay. Well, now I think we can do a couple of graphs. So first I graph and then U graph. So example number 5, f of x equals 3x squared minus 2x squared minus 2. So we're going to start with vertical asymptote. Remember, for vertical asymptote, we'll need to set up denominator to 0, and we are going to have 2x squared minus 2 equals to 0. It's going to give us x squared minus 1 if we divide by 2, both sides equals to 0, or x minus 1 using the formula x plus 1 equals 0. So we have x equals 1 solution and x equals minus 1 solution, vertical asymptotes. Okay. In numerator, we're not going to do nothing, but for horizontal asymptotes, I'm going to label this. This is vertical asymptote. For horizontal asymptote, because powers are same, I'm going to just divide 3 over 2, and that's going to be horizontal asymptote. That's x squared here and x squared here, square and square here. Sorry. X squared over x squared, same power. Same power. Now, for horizontal asymptotes, I'm not going to ask you to find out on which side it's approaching horizontal asymptote exactly. It's too much work for you. But for vertical asymptote, you can do it. It's not very difficult. So what are we going to do, guys? We're going to consider vertical asymptotes separately. So x equals 1, my first vertical asymptote. I'm going to write down f of x equals 3 squared minus 2x over, I'm going to take 2, write down x minus 1, x plus 1. Just factor the denominator, right? So I'll need to know what happens when x approaches 1 plus. So it's like this is 1, and we are on this side of 1, a little bit more than 1. What we can do, guys, you can always plug in 1 in numerator. Numerator usually is not going to be affected by this 1. So if you plug in 1 in numerator, it's 3 minus 2. For denominator, it's going to be a little bit more complicated, because if you choose number 1.1, for example, it's going to be 2, 1.1 minus 1, and 1.1 plus 1. What we see, this one is positive, this one is positive, right? This one is positive, so the result is positive. Well, because this one is going to be very small, 0.1, we are going to have plus infinity. So my graph is going to look like this, nearby the asymptote. Now I'm going to check 1 on this side. So x will approach 1 minus. Well, numerator is same, so I'm going to just use 0.9 here, but you don't need to put 0.9 over here. It's just going to be 3 minus 2. You can put 1, 2, 0.9 minus 1, 0.9 plus 1. When you see greater than 0, this is less than 0, this is greater than 0. This is going to be a huge number, 0. Well, right now it's not huge, but it's going to be huge if you get closer to 1. So we're going to have negative infinity. So the graph is going to be approaching over here. Now we are going to repeat this with -1. What I'm going to do, guys, I'm going to just choose -1 here. And for -1, this parenthesis is going to be always negative, right? Around -1, it's all negative numbers. This one is going to be, well, I'm just going to make it like 3x squared minus 2x, 2x minus 1, x plus 1. The only one place where -1, this -1 is going to place something or change something is this one. -1 here is going to be like what? 3 plus 2, like 5, right? -1 here is going to be 2, -1 is going to give me -2. And here it's going to be like, if you, on the positive side, it's -0.9, for example. So it's negative for 1 minus 1 plus. And we are going to have plus, minus, minus, plus. So it's going to come like this. And if you go on -1 minus, this parenthesis is going to be positive because it's going to be, no, that was positive actually. Sorry, give me a second. Minus, yeah, that was positive. So this was actually minus. This is going to be negative because minus, well, minus side is kind of -1, -1.1. So we are going to have definitely a negative number here. So that's going to be negative. So plus minus minus is going to be plus. So we are going to, sorry, I did a wrong curve over here. It's supposed to be something like this and going to be something like this. Now, guys, I'm going to just graph the whole picture. So I have two vertical asymptotes. 1, -1, and 1. And the horizontal asymptote 3/2. Let's do 3/2. So this is going to be my 1, this is -1, and this is going to be 3/2. So according to this picture, I'm going to have plus here, and 2 minuses here. Well, sorry, it's supposed to be x here and y here. Okay, so yeah, each graph is going to take about like 15 minutes to do, but unfortunately there is no other way to do it. Okay, so now I'm going to give you some self-work. And again, I'm going to solve it myself, but eventually, like, I'm hoping that you will solve it yourself before I do this. For self-work, f of x equals 2x squared plus 7x minus 4 divided over x squared plus x minus 2. Well, what I'll need you to do, find horizontal asymptote, vertical asymptote, and the graph. Okay, so I'm going to count to 5 and do my solution. So 1, 2, 3, 4, 5, and solution. I'm going to start with vertical asymptote. So I'm going to take denominator x squared plus x minus 2 and set it to 0. Actually, here I can factor it, I think. Something like this. And my solutions is x equals 1 and x equals minus 2. Well, again, you will need to know like how it's going to, how it's going to behave nearby. So this is my vertical asymptote, vertical asymptotes. I'll need to find the behavior. Again, guys, my suggestion is to calculate the numerator at point like x1 or, so I'm going to write down near x equals 1. So x goes to 1 plus and x goes to 1 minus. This is 1, this is plus, and this is minus. Again, my suggestion is to just plug in 1 into expression. So we have 2 plus 7 minus 4. And in denominator, keep it in factored form, x minus 1. And here, at plus 2, you can plug in 1, 2. So I'm going to do the plugin in 1. So it's 3. Again, you can plug in actually 1 directly everywhere where it's not turning into 0. So what you have here, 2 plus 7 is 9, minus 4 is 5, this is 3. And if you on this side of 1, it's a little bit more than 1, then it's going to be positive and you are going to have plus. If you are on this side of 1, it's going to be negative because it's 0.9, for example, and you are going to have minus. So I'm going to write out x1 plus, and here x1 minus. It's going to be minus and plus. What does it mean? That it's going to look like this, and it's going to look like this, near the vertical asymptote. Let's repeat same with 2, minus 2. So near x equals minus 2. I'm going to, again, plug in minus 2 everywhere where it's not giving me 0. So 2 here, minus 2 squared plus 7 by minus 2, sorry, minus 4, denominator, minus 2 minus 1, no, 0, and x plus 2. I cannot plug it here because I will divide by 0, obviously, right? So I'm going to calculate my numerator. Numerator is 4 by 2, 8, minus 14, and minus 4. Well, definitely it's a negative numerator, right? Denominator here, minus 3, minus. What I have over here, if x approaches, sorry, minus 2 on the right. So on the right means that this is minus 2. On the right is like negative 1.9. Negative 1.9 is going to give me plus. Minus minus plus is plus. So I'm going to have something like this. If x approaches minus 2 on the left, I'm going to have minus, minus, and more than minus 2, it's minus 2.1, for example, somewhere here, right? What is going to give me? It's going to give me minus, right? Because it's minus 2.1 plus 2, it's minus 0.1. I'm going to get minus, so approaching like this. Now, I'm just going to graph my horizontal asymptote and my approachings to vertical asymptotes. Graph, so my, where is my horizontal asymptote? Oh, I did not calculate my horizontal asymptote actually. So I'm going to write down horizontal asymptote right over here, because the powers are same. It's going to be just y equals 2 over 1, which is 2. Okay. So now I'm graphing my horizontal asymptote, right? My vertical asymptotes, which are minus 2 and 1. 1 minus 2, 2. And my graph is going to be red. So I know that at this side, it's approaching on this side here. Well, I'm not going to create anything. I did not really check it, but I assume that it's going to be like this. Here I have something like this. Why? Because over here it's a negative infinity here. And over here at minus 2, it's positive infinity, like over here. And this side is going to be like this. Okay, that's y, and that's x, and you can put 0 somewhere. Okay, guys, you will need to solve at least 2 problems like this to understand how to deal with them. And I'm ending my second part of 2.6.